This lesson focuses on interacting with LLMs using LangChain. I'll introduce you to the LLM class and explore the various functions it offers, including streaming and batching. Additionally, you will learn about fake LLM classes, which are a valuable tool for development and testing. The LangChain LLM class provides a standard interface for model inferencing. In this class diagram, I'm showing the commonly used functions in the base class for LLMs. The standard interface offers options for synchronous as well as asynchronous inferencing. In addition, there is streaming option that is used for building chatbots or interfaces that receive large amounts of text as response from the LLM. Using this standard interface will improve the portability of your code, as you can easily use a different LLM with a change to a single line of code and the rest of your code will stay the same. Providers of the model implement the LLM class for their models by extending the LangChain base class for LLM. Here are a few examples of the LLM classes. The Hugging Face Pipeline class wraps the Hugging Face Pipeline interface with the LangChain LLM interface, which means that when you will create an LLM with this class, the model weights and other assets will be downloaded and cached locally. All invocations will happen on the local machine. The Hugging Face Hub class implements a wrapper over the Hugging Face Inference Client invocation for inferences. Use of the Hugging Face Hub class leads to the invocation of the endpoint for the model hosted on the Hugging Face Hub. Similarly, OpenAI is for invoking the GPT models. Cohere is an LLM class for invoking the command models. At the time of creation of the LLM, you can pass the model-specific parameters by way of model keyword argument parameter. To learn about the model-specific parameter, you need to refer to the model's documentation. Let me show you how to create and use an LLM class. I've already set up the environment variables, and at this point we are ready to move forward with the creation of LLM. To create the LLM, we need to import the provider class. So from langchain.llms, import Hugging Face Hub. Create the LLM underscore HF equal to Hugging Face Hub, and now we provide the repo ID, which is going to be equal to Google Flan T5XXL. Let's do a quick test here. We'll set up the prompt equal to, I'll use a simple prompt without any input variables. In what year was the first Star Wars movie released? Let's go ahead and try out the invocation of the LLM to invoke, call the invoke function and pass it the prompt. Let's see if we get the answer, and the answer is 1977. What I've shown you here is a synchronous invocation of the LLM wherein the calling thread is getting blocked till the response is received from the LLM or there is a timeout. LLM interface also provides the asynchronous version of the invoke. In fact, asynchronous version is provided for both streaming as well as batch functions. Here, asynchronous means that the thread calling the invoke will not be blocked. As a result, the thread can continue to process while the LLM I/O is waiting to be completed. The benefit of this approach is that it leads to improved performance. Since the asynchronous calls execute tasks concurrently, it reduces the overall execution time. It leads to better resource utilization, and that is because asynchronous operations optimize system resources, especially for high throughput applications. Last but not the least, it helps with enhancing user experience. For example, using async operations, your user interface can become more responsive and would not appear to be hung as a result of its interactions with the LLM. Invoke function waits for the LLM to fully generate its response. With streaming, the caller can receive a continuous flow of generated text in real time. This approach is especially valuable for creating interactive user interfaces like chatbots. Typical user interface responds within 200 to 300 milliseconds, giving the impression of a highly responsive application. However, LLMs often require more time to generate output, which can cause the application to seem unresponsive or hung. By utilizing streaming, the application appears more responsive. This significantly enhances the overall user experience. Next, I'll cover batch processing. Batch in the context of LLM refers to a non-interactive task that processes a collection or list of inputs using an LLM. Unlike the real-time processes, batch invocations of LLMs are designed to run without user intervention, efficiently handling large volumes of data or take care of repetitive tasks. Under the hood, batch processing uses the async invoke function to handle multiple inputs in parallel. The batch size, which determines the number of concurrent calls, is controlled via configuration settings. Batches can simplify the task of bulk processing of inputs. However, it is important to note that while your system may support a high number of parallel calls, LLM providers typically impose a request per minute limit. Exceeding these thresholds can result in batch call failures. Lastly, if you are using a paid subscription, avoid running large batches for testing, as this can incur significant costs. LangChain offers multiple fake LLM classes that simulate the behavior of real LLMs. These classes implement the same interface as the real LLM classes, providing the same invoke, stream, and batch functions. These fake LLM classes are useful for accelerating the development process and controlling the costs associated with the LLM invocations during development. They are particularly effective for quickly building user experience demos and proof of concepts. In this class diagram, I'm showing a few of the commonly used fake LLM classes. The fake LLM list class takes a list of fake responses. When invoked, it returns a dummy response from that list. Fake streaming list responds by simulating a streaming response. You will try out these fake LLMs in an exercise. Let's review the key points from this lesson. LLM providers offer proprietary APIs for invoking their models, which can lead to tight coupling between the LLM and your code. However, by using the LangChain's LLM class, you can enhance your code's portability, making it easier to switch between different LLMs without requiring code changes. Fake LLM classes can accelerate development and help reduce costs during the development phase. In the next lesson, a hands-on exercise will demonstrate all the concepts that I have covered in this lesson. Happy learning, and I'll see you in the next video.